Okay, today in class we went over a review for our final on weather and water, and we did a Jeopardy style review game. So I'm going to quickly go through the answers to that Jeopardy style review game, and I'm just going to go through the different categories. So the first question on there was, what is a molecule? A molecule is the smallest particle of something. If it's water, it's the single two hydrogens and one oxygen combined together. It's not the atoms themselves, but it's the combination of those atoms to make one single molecule of a substance. All molecules with temperature are in what? And the answer to that one is motion. Okay, if they have temperature, they have energy, they are moving around, they have motion. What are some forms of fresh water? And I have there, give me 4 out of 6. There's a whole bunch of different examples here. We could talk about lakes, rivers, groundwater, ice caps and glaciers would be the same thing. Rain, snow, sleet, hail, frost, soil moisture. Okay, pretty much anything except for seas and oceans. They would be salt water. So as long as you pretty much don't say seas and oceans or any kind of body of salt water, then that would be an acceptable answer for this one. Oceans account for how much of the water on Earth? Okay, and I'm looking for the percentage here. So if we take all of the water on Earth, oceans make up 97% of all of the water on Earth, leaving only 3% of the water as fresh water, and a lot of that tied up in ice caps and glaciers. Okay. Next we have, what is the water cycle? The water cycle, okay, we can look at it as a diagram. There's a lot of different things we could say about it, but as simply as I can say it, it's going to be the movement of water as it changes from a solid to a liquid to a gas, and as it moves around to different parts of the earth. Okay, and as it changes from a solid to a liquid to a gas, things like evaporation and condensation are also going to take place, along with sublimation and a few other things. But again, the easiest way to say it is it's water changing from a solid to a liquid to a gas as it moves around to different parts of the surface of the earth. For this one, we're going to get into the air pressure category now. Air pressure is going to be the layers of gas. First question here is, the layers of gas that surround the earth are called the atmosphere. And then we have the daily doubles, which are hidden throughout the game. How does heat transfer to the atmosphere? The way the heat are going to transfer to the atmosphere is going to be heating up the surface of the earth with the sun, and then it's going to re-radiate that energy into the water molecules and the carbon dioxide molecules, which are then going to transfer to the oxygen and nitrogen molecules. So again, the sun heats the surface of the earth re-radiates that heat and also heats up the atmosphere next to the surface of the earth through conduction and radiation, and the water molecules and carbon dioxide molecules are going to absorb that heat, and they're going to transfer to the oxygen and nitrogen molecules. And that question is actually a lot more complicated than 200 points, but because it was hidden behind a daily double, I did move that more difficult question down there with the daily double. Question 3 here. Wind moves from what to what? And that's areas of high pressure to areas of low pressure. Again, areas of high pressure to areas of low pressure. An increase in pressure does what to temperature and density? Okay, as we increase pressure or squeeze a bottle, we're going to push the molecules closer together or into a smaller space, so that's going to increase our density. And we've seen when we also increase the pressure of air, it also increases the temperature of the air. So that's going to be increases the temperature and increases the density. What causes a sea breeze? A sea breeze, and again, you could do a diagram for this one or you could explain it, but a sea breeze is going to be when the land is going to heat up and create a low pressure area over the land, and the water is going to be cooler, so a high pressure area is going to be created over the cooler water, and the wind is going to move from that high pressure to the low pressure, so from the sea to the land, and that's why it's a sea breeze, because it's coming from the sea. What is solar angle? And that's going to be the angle the sun's light hits the surface, or the angle that light would hit the surface of the earth. Which part of the earth receives the most direct rays of sunlight? And that's going to be the equator. So areas around the equator or in the tropics would receive the most solar energy or direct rays of sunlight. How do our eyes work to see objects? Again, light reflects off of objects, and then that light that reflects off of objects is received by sensors in our eyes and then interpreted by our brain, so that way we could understand that information and see the world around us. Updrafts and downdrafts of moist air, particles colliding in storms, are going to give these storms a positive and negative charge. There will be a positive charge towards the top of storm clouds and a negative charge towards the bottom of storm clouds. And this relates to thunderstorms and creating lightning. Okay, and we need those clouds to get a charge. So at the top of the cloud, it's going to be more of a positive charge, and at the bottom of the cloud, it's going to be more of a negative charge, and that's because of the movement of these particles and grapple and things like that moving around inside the cloud. Explain how conduction works as a form of heat transfer. Okay, conduction is going to be a type of heat transfer that's going to take place through contact. So as two objects touch each other, energy is going to transfer from the warmer object to the colder object until they're the same temperature. But that needs to take place through contact or touch. Okay, now we move on to water in the air. Okay, what is a front? A front is going to be the boundary area between two air masses, between a warm air mass and a colder air mass. So that's that boundary area between the two air masses. Next here we have convection is the circulation of fluids. Explain the transfer of energy in a convection chamber that you investigated in class. So we're talking about the smoke chamber or convection chamber here, and what we've seen happen was as the air got close to the ice, we've seen it cool off, become denser and heavier and sink, and then as that air moved over by the candle, it warmed up, became lighter, less dense, and started to rise. Essentially, after it sank by the ice, it created a high pressure area, and then over near the candle where it started to rise, it created a low pressure area. So we got to see that circulation of air. Warmer, lighter, less dense air rising, cooler, heavier air becoming denser and sinking. What is the difference between dew point and humidity? Okay, dew point is the temperature at which water vapor is going to turn back into a liquid, and basically condensation is going to take place. With humidity, we're looking at the amount of water vapor that's in the air. A lot of times that's going to be considered relative humidity, and that's going to be the amount of water vapor in the air compared to how much water vapor the air can hold. But again, dew point is a temperature, humidity is a percentage or amount of water vapor that the air can hold. Another daily double. Why does a watery mist form on the mirror after a shower? The warm, moist air from the shower is very, very energetic and extremely saturated. When it comes in contact with the colder mirror is going to cool it off to the dew point, and like we said in the previous one, when it gets to the dew point, condensation is going to take place, and then it's going to leave that dew behind on the mirror because it can no longer hold on to all of that water vapor, and it becomes dew stuck on the mirror. Explain how clouds form. There's a couple steps to the way clouds form. One of the first things that's going to happen is the sun is going to heat up water at the Earth's surface, and it's going to evaporate water to get moisture into the air. That warm, moist air is going to start to rise. As it starts to rise, it's going to continue to cool as it rises. When it cools enough, it's going to get to the dew point. When it gets to the dew point, condensation is going to take place, and the water droplets then are going to stick to condensation nuclei, or little imperfections, or dust and smog and dirt in the upper atmosphere that will then allow clouds to form, and the clouds stay up because as condensation takes place, energy is given back off, and it kind of reheats the clouds almost like a hot air balloon. Conditions of the Earth's atmosphere at a given time and place are called weather. Okay, so as we get back to the 100-point questions, they get a little easier. So when we're looking at specifically what is going on at a given time and place, that's what we're going to call weather. Okay, the amount of solar energy that strikes different parts of the Earth determines what, and that's going to be the seasons. okay, how hot or cold the area is going to be. But when we are tilted towards the sun, we're going to get more direct energy. It's going to be summer. When we're tilted away from the sun, we're going to get less direct energy, and it's going to be winter. Okay, what's an air mass? An air mass is a mass of air that is all essentially the same temperature and moisture. So when we look at air masses, we're going to be looking for an area of air with similar temperature and water vapor levels or humidity and pressure as well. What is the term for the way that light covers a large area when it hits the surface at an angle? Okay, and that's going to be beam spreading. Beam spreading. So when light hits the surface and spreads out, that's going to be beam spreading. How much beam spreading takes place depends on a lot of the seasons. If it spreads out a lot, it's usually winter, and if it doesn't spread out a lot and it's very concentrated, then it's most likely summer, or it's going to be more likely to be summer. Differential heating by the sun is going to cause wind. Okay, because different parts of the earth are going to heat up at different rates, it's going to create high and low pressure areas, and high and low pressure areas is going to cause air to move. So air is going to move from the high pressure areas to the low pressure areas, and that's going to be wind. Okay, again, going back down to temperature and density for 100. The objects, or this object provides Earth with much of its energy and drives much of its weather, and that's going to be the sun. Okay, without the sun, we wouldn't have any weather. We're not going to have any differential heating. We're not going to have high and low pressure areas. We're not going to have life on Earth. But the sun is a major force for driving weather and creating much of the weather on Earth because of creating different warm and cool areas. Which requires less energy to heat up, soil or water? Okay, soil is going to heat up faster, so soil requires less energy to heat up. Water requires more energy to heat up, but water will stay hotter longer. Soil, while it heats up faster, because it requires less energy, it will cool off faster. So the answer to that one is soil. What is volume? Volume is the amount of space an object takes up. Okay, the amount of space an object takes up, as opposed to what our next one is, mass. Okay, mass is going to be how much matter or stuff is inside an object. The amount of matter inside of an object is going to be its mass. And weight is something different. Weight is the pull of gravity on an object, or the amount of force of gravity on an object. Okay, and again with temperature and density, one of the things you're going to have to do on the test is calculate density. So we're looking at two solutions here, and we want to find out which one is denser. So solution 1 has a volume of 30 cubic centimeters and a mass of 12 grams. So when we go to calculate the density for that one, we're going to take the mass, 12 grams, and divide it by the volume, 30 cubic centimeters, and we're going to get 0.4 grams per centimeter squared, or cubed, sorry, centimeter cubed, cc. And then in the second solution, we're going to have a volume of 35 centimeters cubed and a mass of 42 grams. So when we do that, we're going to go with 42 grams divided by 35 centimeters cubed, and we're going to get a density of 1.2 grams per cc. So we're going to see that solution 2 is going to be denser. Again, to calculate density, that's going to be the mass divided by the volume. And we get to the last question on here. Why do we have shorter days in the winter than in the summer? And that has to do with the tilt of the Earth. So in the summer we are, in the winter we are tilted away from the sun, and because we are tilted away from the sun, we are going to not have as many hours of sunlight, or as the Earth spins, we're going to spend more time on the nighttime side, not being able to see the sun. So again, it has to do with the tilt of the Earth, and in the winter, because we are tilted away from the sun, we are going to not receive as many hours of daylight, as opposed to in the summer, when we are tilted towards the sun and we receive longer hours of daylight. We are in the daytime side longer and in the nighttime side less. So again, it has to go back to the tilt of the Earth. If you have any questions, please feel free to stop by in class and ask.